power functions and polynomial functions, and essentially kind of focus on the end behavior based on the leading term of each of these functions. All right, and then we'll get into a little bit of making sure we know how to find the x and y intercepts of polynomial functions. Okay, so a power function is a function. Let me change back to my original color. Sorry about that. A power function is a function with a monomial term, okay, that is the product of a real number, a coefficient, and a variable raised to a fixed real number, okay? So this is kind of the general form as you look at these power functions, and you can see most students recognize these ones on the left side, right? These are the constant, then we have the linear function, then the quadratic, then the cubic. The ones on the right-hand side might be a little bit more difficult to see, but if you write this as x to the negative first power, x to the negative second power, we've been working, you guys just did an IXL link in the last few weeks about rational exponents. So this is x to the 1/2 power, and then the one below it is x to the 1/3 power, right? So technically all of these are monomials, all right? And then you are raised to a fixed number here, right? So a fixed power. All right, so look at these three. If I were to multiply 2x times 4x cubed, I get 8x to the 4th power. And so this takes care of it being a power function. This one has two terms, right, connected with addition. So it's not a monomial, it's a binomial. So you'll see later in this lesson, we call this a polynomial function. And then we've talked about this one, this last one here, h of x, before, right? This is a rational function. All right. So let's talk a little bit about end behavior. You would have gone over this in your Algebra 2 class, but just to make sure that you remember how to do this, it's all about looking at the leading term, all right? And from there we get the leading coefficient, and we also get the degree. So if you know all of these things, then you can explain what's going to happen as you move to the left forever, right, towards negative infinity in your x values, and to the right forever towards positive infinity in your x values. Okay, so you can look at, let's start with the even powers. So even powers would be like 2, 4, 6, 8. So the idea is here that when you have an even power, your end behavior, they're going to open the same direction. All right, so you can see this first one, they're both ending going up. And in the one below it, they're both opening down. Hopefully this is the more straightforward one. This is if you have a leading coefficient that is positive, it is going to go open up. Excuse me. If you have a leading coefficient that's negative, you're going to open down. The one that's probably a little trickier is the odd power, right? So odd numbers like x to the 1st power, x cubed, x to the 5th power, right? When it's odd, your end behavior is going to be going the opposite direction of each other. I always tell students the way that I think about it is, if you think about your most basic one here, right, a positive 1x cubed is always going to look like this in this box. And so if it has a negative leading coefficient, then I'm going to end up making it like this bottom box. So starting the top left to the bottom right. Anyway, it's just some practice, you'll get it. So let's try some end behavior with these power functions. So we look at x to the 8th. All right, so let's go with our leading coefficient, which I'm going to use is LC. Our leading coefficient is 1, which all I care about is that it's positive 1. And then the degree is 8, but I care about that that's even. So if I were to do a quick little sketch of the end behavior, right, if it's an even degree, we know they have to go in the same direction for our end behavior. And since it's positive, they're both going to open or go up. So in terms of the end behavior, you write this as x approaches negative infinity. So as we go to the left forever, our function f of x, so our y values will go up, so approach positive infinity. And as x approaches positive infinity, so moving to the right forever, our function will also approach positive infinity, so the y value is going up forever. So that's kind of the you know the strategy when you want to do these and how it works. So let's try another one. So leading coefficient, this time it's -1 again. What I care about is that it's negative. And then the degree is 9, which is odd. So the sketch here might be a little trickier. Again, if this was a positive leading coefficient and with an odd degree, then I would have bottom left to top right. But since it's negative, I'm going to have top left to bottom right. So that's going to change how this works when I describe the end behavior. So as I'm moving to the left forever, the function is approaching infinity. And as I'm moving to the right forever, the function is approaching negative infinity. All right, that's essentially how this works. I'll do this one a little faster here. So we've got the leading coefficient, which is -5. Again, I just care that that's negative. The degree is 4, which I care about that it's even. All right, so since it's even, we know it's going to be the same direction. And since it's negative, both are going down. All right, so using my symbols, I'll say it as I write it. So as x approaches negative infinity, the function is going down. And as x approaches positive infinity, the function is going down. All right, and so that's kind of the strategy, and hopefully that feels like a review. And if it's not, I'll show you guys in class kind of a fun way that I remember it. Okay, so let's transition to polynomial functions. Not really going to change a whole lot in terms of how we do the end behavior here, because we're really just going to focus on that leading term. So essentially becomes kind of like we just focus on if it were a power function with a monomial. All right, but this is a little different. So with polynomials, all right, you're looking at having multiple of these, and there's a little typo here. This should be starting with x cubed, and then so you want to put it in order from the highest exponent to the lowest. All right, so that's where we get our degree. So don't just look at the first thing if you haven't checked to make sure that it is written from highest exponent, down to the lowest. Okay, so which of the following are polynomial functions? So I'm going to multiply 2x cubed times 3x and get 6x to the 4th power plus 4, which is a polynomial function. You'll notice that we have x to the 4th power, then we don't have x cubed, we don't have x squared, we don't have x to the 1st power, and we finish with a constant. All right, this next one, if I distribute the negative x, I get negative x cubed plus 4x, which is also a polynomial function. And then finally, this 5 times the square root of x plus 2 is not a polynomial function. It's called a radical or square root function. All right, so again, I want you to stress that I know that it looks like there's new stuff going on here. This is really not. It's just this idea that when you have a polynomial function, you focus on the leading term once make sure it's written in that order. And then you just think of it as if it were just a power function to get that end behavior, okay? So let's kind of practice that. We're going to make sure these are written in that form that has the highest exponent first. So negative 4x cubed plus 2x squared plus 3. All right, so this is going to be in that standard form. And then if I want to find the degree, so the degree is 3. The leading term, so LT, the leading term is negative 4x cubed. And the leading coefficient, or LC, is negative 4. All right, so again, this process, you practiced before and you're going to practice again to make sure you know how to find the end behavior. All right, so let's do g of t. So g of t is going to be negative 2t cubed plus 5t squared plus 7t. So the degree of this one is also 3. The leading term is negative 2t cubed with the leading coefficient of negative 2. All right, this last one, h of p, is going to be negative p cubed plus 6p minus 2. So they all ended up having the same degree of 3. All right, the leading term in this case is negative p cubed, which gives me a leading coefficient of negative 1. Okay, so since they all have the same degree and the same negative leading coefficient, their end behavior would all actually be the same. Let's do another one here. All right, f of x equals, let's write it, negative x to the 6th power plus 4x squared plus 2x minus 6. So our degree is 6. The leading term is negative x to the 6th power. And the leading coefficient is negative 1. So the end behavior here, since it's an even degree with a negative leading coefficient, you would be both would be going down for your end behavior. Okay, so let's talk about transitioning to end behavior for these polynomials. As I mentioned, it's really not going to be any different than your power functions because ultimately you're just focused on the leading term. So it feels like it's a monomial when you do this. So we're going to focus on the leading term. All right. And then it essentially becomes that we're thinking about this as a power function just consisting of that leading term. So let's look at this one here. All right, so let's do our leading coefficient. All right, so our leading coefficient and our degree. All right, the moment that I see that the end behavior is going in opposite directions, I know the degree will be an odd number. And then for the leading coefficient, this looks like how I would graph x cubed, which going from bottom left to top right. So this is going to be a positive leading coefficient. All right, we'll get to a place where you can actually, figure out what this is based on the intercepts. All right, let's do this next one here. So we have a leading coefficient and a degree. Again, with both opening in the same direction, I know my degree is going to be even. And since they're both opening down, my leading coefficient will be negative. All right. So let's kind of take this one, which is in factored form. We're going to put it in general form, which just means I need to expand it and multiply it all out. So let's do that first. So I have negative 3x squared times, if I distribute x times x, I get x squared. X times 4 is 4x, minus 1x gives me positive 3x, and then minus 4. Now I'll distribute that negative 3x squared to get negative 3x to the 4th power, minus 9x cubed plus 12x squared. All right, so if I find the leading term is going to be negative 3x to the 4th power. The degree is going to be 4. All right, so again, what I care about is the leading coefficient, right, is negative, and the degree is even. So if I were to sketch what this looks like, it's going to open the same direction, and because the leading coefficient is negative, that direction is going to be down. So if I were to write the end behavior, I would write as x approaches negative infinity, our function is approaching negative infinity. And same thing as if I move to the right forever, our function will approach negative infinity. All right. So let's go ahead and do these last couple, and then we'll be finished. Just this idea of, do you know how to find the intercepts of these polynomials? And again, obviously, you're able to use Desmos on the tests that we're taking in this class, so you could type these in, and you could see where it crosses the x-axis and the y-axis. But we can do this algebraically as well. For the y-intercept, right, I think that's the easiest one for looking at pretty much any function. But we're going to evaluate the function at 0. All right, so if I plug in 0, I get 0 to the 4th power, which is 0, minus 4 times 0 squared, which is 0, and then minus 45. So my y-intercept is going to be 0, negative 45. Now to find the x-intercepts, that's a little bit more challenging when you have a polynomial function, because you're going to actually make y 0, which means I'm going to set this function equal to 0. But this is actually something that I can factor in. I showed you guys in the previous unit that if you just think of this as x squared and x squared, you can actually think of factors of negative 45 that add to negative 4. So that's going to be negative 9 and positive 5. All right, so if I keep factoring, I get x minus 3, x plus 3, right? That's the difference of two squares. X squared plus 5 cannot continue to be factored, so I leave that alone. So I'm going to get two x-intercepts. You might be thinking, but Mr. Frederick, don't you have more? Well, so I'm going to get 3 and negative 3. And the reason that I end up not worrying about these two is because if I were to set that equal to 0 and move over the negative 5, or the 5 to be a negative 5, when you take the square root of both sides, you get x equals plus or minus I times the square root of 5. All right, and you guys know that when you see that letter I, that means you have imaginary or complex roots. So you're not going to actually see those in terms of crossing the x-axis. So we really only have two x-intercepts. We have 3, 0, and negative 3, 0. Even though if you were solving this for the number of solutions, you would have technically 4 solutions, right, for that degree. You just have 2 real and 2 complex ones. Let's do one more. All right, so let's do the y-intercept again first. I think that's the simplest here. So I'm going to plug in 0. We get 2 times 0 cubed minus 6 times 0 squared minus 20 times 0. Now this case, or in this one, we don't actually have a constant. Everything has the variable x. So my y-intercept is going to be 0, 0. Now because of that, we know that one of the x-intercepts will also be 0, 0. But we're going to have some other ones. All right, so set the function equal to 0. I'm going to factor out, it looks like I'm factoring out a 2 and an x. Give me x squared minus 3x minus 10. If I keep factoring, I'll get x minus 5 and x plus 2. All right, so my 3 x-intercepts will be 0, as we already knew, positive 5, and negative 2. So I'll write those down. So 0, 0, 5, 0, and negative 2, 0. All right, and that's it, guys. So don't forget to make sure you watch this. Obviously, you finished watching. If you're listening, great job. Make sure to go to the links to practice these concepts. Good luck.